Hi folks, we appreciate the discussions. We're going to go ahead and get started with the next panel here. As we begin this session, I'd like to thank a couple more sponsors that we have. We'd like to say a thank you to CHS, Monsanto, and the Rapid City Pier and Eastern Railroad. Give everyone just a moment here to get sat down. Thanks again once again to our sponsors. We appreciate all your support. So our third panel discussion is going to focus on a topic that's very important to producers and probably one of the most important things to producers and one of the most unpredictable as well, and that's the weather. Weather dictates the quality of our pastures, markets, crops, and so much more. During this session, our panelists will try to discuss some of the challenges that are faced by producers and try to unlock some of the secrets about what the weather will bring us this year. So. Our first panelist today is Dr. Dennis Toddy, who's been the state climatologist for South Dakota since 2003. He conducts research on long-term climate trends and their impact and interaction on ag and water, and develops tools for utilizing data in ag and water decision-making at South Dakota State University. He is a frequent speaker on long-range climate outlooks, climate trends, general climate, variability, and climate change information. Darren Claybo has been the South Dakota State Fire Meteorologist and faculty member at South Dakota School of Mines and Technology since 2010. As a faculty member at the School of Mines, he teaches a variety of meteorology courses and is an active researcher with focus on the fire-atmosphere interactions and wildfire climatology. In his capacity as the state fire meteorologist, he works in collaboration with interagency officials on the prevention and suppression of wildland fires and in the preparation and execution of prescribed fires. And our third panelist for this discussion is Eric Snodgrass. Eric is the Director of Undergraduate Studies for the Department of Atmospheric Sciences at the University of Illinois at Urbana-Champaign. He advises all undergraduate majors and minors in atmospheric science and supervises graduate teaching assistants and master's students. Snodgrass's research focuses on K-12 science education as well as weather forecasting applications in financial markets. He is also the co-founder of Global Weather and Climate Logistics, LLC, which is a private company that provides logistical guidance and solutions to weather-sensitive financial institutions. Gentlemen, welcome to the Governor's Ag Summit. We thank you for joining us. This panel discussion will be much like the session from this morning. We'll hear from each of the speakers, and then we'll have some time for questions afterwards. So. Let's give our panelists a warm round of applause to welcome them to the stage.
Okay. Good afternoon. We have the coveted position of talking to you right after lunch, so no snoozing allowed. When I was a TA at Iowa State, I had the luxury or wonder of helping with a class that occurred at 2 in the afternoon in the largest lecture hall on campus. Everything was on slides. You really didn't have to take any notes because the professor sold you a notebook, and the room tended to run hotter than average anyway. And there were very few people that stayed awake during the whole time. So we're going to do this in 3 parts. I'm going to set kind of a climate background. I'm talking about a little bit about the climate of South Dakota and how it's changing as some of the drivers in the way of agriculture. Darren will take off from there and talk about wildfire issues, and then Eric, thank you. God, Eric will talk a little bit more about this coming year. So I think we have some slides here, if we can go ahead and load those up. South Dakota is a very much land of extremes that we know about. We've heard a little bit about those this morning already. We have large extremes because we are in the middle of the North American continent, which is a big driver and a big controller. So there's some pluses and minuses that relate to our climate because of our position in the middle of the continent. And I'm hoping they're throwing slides up there, otherwise, there we go. All right, okay. Here we go. Pictures of some of our extremes: our 2012 drought, the blizzard in 2013, and the Missouri River flood in 2011. Some people have said that South Dakota's climate was fairly benign before I came here, so I guess if you can blame me for it, that's fine. That's okay. Just a little bit about the background of where we are. In the way of being in the middle of the continent, we are on that transition zone from the relatively moist Midwest to the very dry plains. And that area is an area that can be very agriculturally productive based on how you use it and managing it right, but it is changing, and we're going to talk about some of those changes here in a little bit. We go from about 26 inches of precipitation in the southeast part of the state to about 15, 16 in the northwest part of the state, with a little blip over the Black Hills that is a large transition. Temperature, on the other hand, is much more latitudinally based. The further south you are in the state, the warmer generally, the further north you are, the cooler, especially the northeast part of the state. But there's an interesting contrast that comes with this, and it's a little bit of an offset that occurs in the way of when precipitation and temperature occur within the state that cause some of the issues. Throughout the state, the peak temperature time is midsummer. Mid-July is the warmest throughout the whole state. But from a precipitation standpoint, the peak precipitation, we've actually coming past the peak in the western part of the state, which Lynn Tiersma mentioned yesterday, or mentioned this morning, the lack of precipitation that's occurred in May. That's their peak precipitation month. The peak precipitation time, East River, we're coming up on that right now, but so that is closer to that peak temperature time. West River, the peak precipitation and temperature are offset, so that's why crops are done a little bit differently and have to be done a little bit differently around the state. Obviously, we know climate impacts yields, and Eric's going to show you another couple slides about some of these issues. We can look back at some of our corn yield trends and see, particularly when we've had those big loss years, that are related to big climate events that occur during those times. From a climate changing perspective, that's helping to drive part of what is happening in the way of agriculture around the state. I show here the acres of corn harvested in 1981 compared to 2013, and you see a very distinct difference in where corn is being planted. Certainly genetics have had a large role in this, which they have, but there are also some changes that have occurred in climate which help to make corn more conducive and more able to be grown in parts of the Dakotas. So let's talk about some of those changes. And these are derived from something called the National Climate Assessment. It's an assessment that is mandated by Congress, that is throughout the federal agencies, to be done about every 5 years. This one came out in 2014, so we'll be starting to work on the new one coming up. And just showing you what has happened from a larger scale basis. What shows you here is this is the observed precipitation change over the last century. And the greener a place is, the more the precipitation has changed. The greenest areas have seen a greater than 15% increase in precipitation over the last century. And you can see that South Dakota, North Dakota, Minnesota are ground zero for some of the biggest changes in the way of precipitation which we've seen. All through the middle part of the country we've seen it, but South Dakota statewide has introduced more precipitation. That has good and bad points about it. The drier areas of the state, more precipitation generally has opened up options in the way of what crops you can grow. The areas that are a little bit wetter has introduced water management issues, which we've seen in the way of more tile drainage, more erosion, which was mentioned this morning, and some of those issues. We'll talk a little bit more at those as we go along here. Unfortunately, part of the increase has also come with increases in heavy precipitation, more precipitation occurring in larger events. And most people in agriculture have been in a couple Corn Belt-wide projects. They've talked to, there is realization within the Corn Belt that this is changing. We're getting more big events. And most everybody I talk to, once you start talking about 3, 4, 5-inch rainfall events, no one says there's anything good about those, because there's really not much good that can come with those unless you're looking for runoff for a lake or pond or something like that. 3, 4, 5-inch rainfall amounts produce lots of erosion type issues. And just to kind of show you how South Dakota has changed over that time period, this is a graph showing average annual precipitation for each one of those circles from 1895 until 2015. And then the blue line shows the overall trend. So you can see a lot of variability, lots of ups and downs with, the 1930s, some of the low points, some in the 50s, a couple of those in the 70s, and then a few of those more recent years, 2002, 2006, and 2012 were some of the big downside ones. But you see a lot more of the high values and many fewer of the lower values. So that's part of the issues we deal with too, is these variability issues are with us and they're not changing, they're staying with us. From a temperature standpoint, we are also getting warmer. This is also from the National Climate Assessment showing the changes in U.S. temperatures over the last century, with the reddest areas being greater than 1.5 degrees Fahrenheit increase. That really the northern U.S. and the western U.S. are the two places where we've seen the most increase. Oddly enough, that southeastern part of the country, not so much of an increase and actually a slight decrease in some places as we've gone along. Our temperatures are changing, and it's very much a couple of very interesting things we want to point out. One of which is this is a South Dakota annual average temperature from January through December. You can see, again, a lot of variability, 30s with some of the warmer temperatures overall, and then kind of a small cooling period there up until about the late 70s, and then some pretty strong increases since then that we are getting warmer overall. But there are some interesting pieces when we start to break that down. Let me ask you by a show of hands. If I said our summers were getting warmer or colder or staying the same, I'd like to see what you think. How many of you say our summers are getting warmer? How many of you say our summers are getting colder? How many of you say they're staying the same? Okay, very interesting. You guys haven't heard me talk. Our summers are getting warmer, but they're getting warmer in a way you would not expect them to. I've broken this down by, this is actually northeastern South Dakota, but it would be very similar if we did this in any other part of the state. On the upper left-hand side, that's average high temperatures for the summertime, and we can consider summer June through August. On the lower right-hand side is minimum temperatures for June through August. So when you combine those, we're getting warmer. But our summertime highs, and especially if you look at, say, the last 20 years or so, it's almost a bit of a drop depending on where you are in the state. But it's our minimums that are driving our warming, not as much our maximums. And we're seeing that throughout a lot of the year, which presents a lot of different issues in the way of agriculture. It presents some different issues in the way of additional heat stress on livestock, because we're seeing more events of those kinds of things happening. Some of that warming is also leading to an increase in our frost-free season, longer growing season. It allows us to plant longer varieties and to move into places, move corn or soybeans into places where we typically hadn't done them before. One more thing to talk about from a seasonal basis is we're going to break this down into seasons, looking at precipitation by seasons. And what you're seeing here is the seasonal precipitations. Upper left-hand side is the spring, the upper right-hand side is summer, the lower left-hand side is fall, and the lower right-hand side is winter. And this is for northeastern South Dakota. I chose this one. It varies a little bit by part in the state. But what it shows is some of the interesting pieces of what's happening in the way of precipitation changes. If you look at that blue line, you see the spring actually over time. There's actually a slight decrease in precipitation northeast South Dakota over time. Summer, a little bit the same thing. But in the fall, especially northeastern South Dakota, we've seen an increase, more precipitation in the fall. Other places in the state, we're seeing more of that springtime. We're really not seeing much increase in the way of midsummer precipitation. It's more the transition seasons. And for most people doing row crop agriculture, you ask them, when do you want precipitation? During the harvest or planting, or during the middle of the season? They'll say middle of the season. But that's not the way that precipitation's happening. It's more happening during the transition seasons, less so during the peak water holding time. So it's presenting some water management issues for us. And also lots of bigger extremes. We've seen many of those in places around the state. Just a few fun ones. Lead in 2013 had near 50 inches of precipitation. Lemon in the northwest part of the state had almost double their annual that year, 35 inches. I drove through there that following winter, and they had corn they couldn't harvest. How many times would you expect to see corn that was not able to be harvested because it was too wet in northwestern South Dakota? Just a very odd situation. Brookings in 2010, we beat our record by a huge amount and actually had a major flood issue in the fall. We don't expect to have flood issues in the fall. We expect to have them in the spring. And breaking those records by large amounts. One other issue I'll bring in, just kind of a sidelight issue, along with the additional moisture is more moisture in the air. So we have higher dew point episodes. From a livestock standpoint, a human comfort standpoint, we're seeing some of those issues going on, becoming a bit more frequent as we've gone along. One more about the variability issue. We've talked about longer term changes, larger changes. The variability issues within these are not going to go away. We still have the variabilities in the system. Those still exist. You're just kind of shifting the whole state and that variability to a higher level and to a difference. So that's something that's not going to go away with that. So just to kind of put these in agricultural perspective, some of the major changes that we're seeing: wetter, bigger events, we've got to do soil management different. There was discussion this morning about soil management, soil health, less tillage. Those are things that we recommend doing as a way of protecting your soils. There's another place I drive by on I-29, following off the comments this morning. This person loves to do tillage. And 3 times in the last 5 years, they've had greater than a 4-inch rainfall event in the spring before the crop was very high, and they've moved a lot of soil. Changing time of year precipitation, more soil and water management issues. Longer growing seasons, we can take advantage of that, looking at hybrid changes. The increasing moisture content, I talked about the dew point issues. More moisture around also increases our disease risk. So that's something we need to continue to work with some of our disease risk issues. Warming winters, still work to be done on changes in disease risk, overwintering of diseases and insects, and then just bigger precipitation extremes, trying to deal with those. So I will wrap it up there, and we'll hand it off to Darren. And let's go ahead to move on to the next set of slides.
Well, good afternoon. I hope you all are well settled after lunch. I'm also an incident meteorologist, so I go out on these large wildland fires all across the United States, western United States, and I have the ability to talk to wildland firefighters. And fortunately for me and for you guys, most of those firefighters have been working off like 5 hours of sleep and are all caffeinated up, and so they're really groggy. So if you hear the inflection of my voice change a lot, it's to try to wake you up. So I'm going to talk a little bit about wildfire weather and agriculture. Like I say, I'm a fire meteorologist. I'm a meteorologist by trade that just kind of got lobbed into the wildfire world. I love it. I live it. I breathe it. That's what I do now. And I'm going to assess kind of wildfire risk across the state of South Dakota from a weather and climate perspective. And fire and agriculture are intimately related. Drought years can produce bad fire seasons, can also produce bad egg seasons for our producers across the state. So I'll start with just a couple of basics. So wildfire and climate are going to be inherently linked, right? South Dakota has both forested ecosystems, like across the western part of the state, and mixed grass prairies. Both are adapted to fire in our state. They're used to fire. They like seeing fire. And in terms of our climate, different drivers of the wildfire seasons we're going to look at are temperature, precipitation. Precipitation is probably the biggest one. Precipitation and drought definitely go hand in hand. And then how that temperature and precipitation drive the fuel matrix that's out there. Whether we're in a forested ecosystem where we have timber litter on the ground that'll burn, or whether we're in the grasslands of South Dakota where we might have thick thatch like we do this year. And then how that all relates back into the overall wildfire scenario. So just kind of a fire behavior overview. What do we look at? For wildland firefighters, we look at 3 things that drive fire behavior. We look at fuels, topography, and weather. Right? Fuels are really driven by the local climate, whether you're in a forested ecosystem or a mixed grass or tall grass prairie in eastern South Dakota, western Minnesota. Topography, largely unchanging. Fuels can change on a year-to-year basis, decade-to-decade basis, but weather is really the driver of the everyday fire activity that we look at, and everyday weather is driven by year-to-year climate or decade-to-decade climate. That weather definitely has linkages with fuels, going back into especially precipitation and in terms of climate. Drought. So those are the 3 things that I want to sit and consider, really considering just fuels and weather, because those are the things that change on a year-to-year basis. This is just a map of the land cover across South Dakota, and I think we're all pretty familiar with this. If we look at the Black Hills of South Dakota, it's a ponderosa pine-dominated ecosystem. However, there's a lot of variations in the ecosystem from the southern Black Hills, which receives roughly 15 inches of rain per year, to the northern Black Hills, where there's a lot more Black Hills spruce or aspen mixed in that might get 25 to 30 inches of precipitation every year. Plains of western South Dakota, anywhere from 15 to maybe 18 inches of precip. Really, it's a short to mixed grass prairie. A lot of cattle production in that part of the state. But then if we go to the eastern side of the state, it's mostly row crops, cropland, right? And each of these different distinct ecosystems has a different wildfire seasonality associated with them. The other thing about western South Dakota is there's a lot of ponderosa pine, I call them stringers, especially across the southwestern part of the state. When we get down in the Pine Ridge, Rosebud reservations, there's a lot of ponderosa pine in those ecosystems as well, and those act a lot like the Black Hills National Forest when it comes to thinking about drought, climate, and wildfire. So I'm doing some research right now, and I'm breaking South Dakota down into its 9 climate divisions. There's basically 3 across western South Dakota, 3 down the center of the state, and then 3 over eastern South Dakota. I'm going to talk a little bit about fire climatology and precipitation in each of these different zones across South Dakota so we can get a better idea of our overall wildfire risk across South Dakota from January through December. So this is the Black Hills Climate Division, and in blue is going to be the acreage burned, and that's read by the number on the left side of the graph. In red is the total precipitation, which you can read by the right side of the graph, and it's all binned by month. So it's month January through December on the bottom of the graph. And the first thing that you can pull out from this is May and June are the 2 wettest months in the Black Hills Climate Division. As a matter of fact, May and June are the 2 wettest months no matter where you are in South Dakota. So that precipitation chart won't change too much. There's actually a little secondary precipitation spike we get in the year in South Dakota, and that generally occurs late September into October. We sometimes get those late season rain events or even early season snow events that'll occur then. But in the Black Hills National Forest, our fire activity typically peaks in July and August. This is data that goes from 1970 to 2011. And that's really just driven by dry conditions in the summertime. If we don't get precipitation in May and June, we tend to burn in the Black Hills. Why? Well, if we're short 6-7 inches of rain in May and June, July and August are our 2 warmest months, we're going to obviously burn in that particular ecosystem because that's a fuels-driven ecosystem. There are fuels-driven fires that are out there. If we look at the northwestern part of the state, we'll look at the southwestern part of the state first. There's a slight peak in overall acreage burn in April, but primarily speaking, Southwestern Climate Division in South Dakota typically burns in July and August as well. That April peak is interesting. There's a lot of grass down there. April is after the snow already melts and before spring green up. And so we can get a lot of these, we call them shoulder season fires, where a cold front will come through, it'll get really, really windy, warm for a day, and we'll get big grass fires that race across the prairies. But primarily speaking, even in the Southwestern Climate Division, our peak fire activities in July and August, really driven by a shortage of precipitation in May and June. If we look at, I skipped past the Northwest, maybe it's not in here. The Northwest is the same way. If we look at the North Central Climate Division, now you start to see a shift in acreage burn to late summer and even into early fall. July is one of the peak months, as is October. So central South Dakota has a different fire climatology than does western South Dakota. Typically speaking, our biggest fires occur in the fall time. And so this goes back to kind of a risk assessment. When are you most at risk for large fires? If you're producing cattle across central South Dakota, replace the bearings in your trailers. There's different ways we can mitigate fires across this too. The other thing I want to point out is a lot of the fires in July and August are caused by lightning. But all the fires that we see, nearly all the fires that we see in October or April are human caused. We just don't have the lightning events like you do during the prime time of the summer. If we look at central South Dakota, again, the fire season peaks in early fall, mid-fall, right? It's after the grasses have already cured for the season. We get these shoulder season cold fronts. You guys all know the strongest winds we get, fall, winter, and spring, right? Well, spring and fall, if there's no snow on the ground, the grass is cured out and it's very susceptible to fire. In central South Dakota, it's more susceptible in the fall than it is in the spring. If we look at south central South Dakota, again, we see this peak in July, but then again, we see a peak in October. Let's look at eastern South Dakota. Now the whole graph shifts earlier in the season. Eastern South Dakota, with the row crops that are out there, the stubble fields that we do have, the cattails that are out there, peak fire season is typically March, April, even into early May some years. But April is really the peak of wildfire activity in the eastern side of the state. So here's the chart for the Northeast, and that's really just post-snowpack and pre-green up, right? And there's a lot of ag burning that goes on. Unfortunately, there's a lot of ag burning that probably escapes too. And so a lot of these, and by the way, these are all wildfires too. This doesn't include prescribed acreage across the state. If we look at east central South Dakota, again, we see a peak in March and April. Slight peak there in July, probably was 1 or 2 big fire years that skewed the data set, but I think most of the fires occur in March and April. If we look at the southeast, it even pushes back into February. Southeastern South Dakota typically loses its snowpack a little bit sooner than northeastern South Dakota. It's a little bit warmer there, and so their fire season is pushed back just a little bit. And I'm going to try to tie this all together now in terms of climate change and climate variability. So here's just kind of my overarching chart that shows what I just described. Western South Dakota, our peak fire season is summer. Central South Dakota, it does peak in the summer and in the fall, but then in eastern South Dakota, our fire seasons typically peak in late winter and early spring. In eastern South Dakota, the vast majority of fires are human caused. So drivers of fire growth, fortunately my picture got too big here, But in the Black Hills, it's drought. That is the primary driver of the fire season in the Black Hills National Forest. If we don't have drought in May and June, we do not, historically speaking, have a fire season. And there's a lot of production that goes across the Black Hills as well. There's a lot of cattle that are in the Black Hills. So again, no drought, little fire. If we go to the grasslands, maybe central South Dakota or the west central prairies of South Dakota, really we're talking about cured fuels and wind. So we either have to be pre-green up or post-green up. In central South Dakota, it's mostly during those, I'll say the post-growing season, mostly during those times when we have cured grasses that are out there, and we got strong cold fronts that push through in the fall time, and you get those large fire growths. Some of the largest fires we've seen in South Dakota have occurred in late October, early November. We're talking fires that have burned over 50 to 100,000 acres. The croplands of eastern South Dakota, it's really post-snowmelt, pre-green up, February, March, and April. It's those spring frontal passages that we're really looking at because those are the days when we get those hot, dry, relatively hot, dry conditions for, say, the months of March and or February. So I'm going to go back to a graph that Dennis just showed, and this is South Dakota precipitation statewide, January through December, averaged out from 1895 on the left to present day on the right. And from a fire management perspective, variability is the thing we're concerned with, right? If we have, like we have this year, 3 prior years of wetter than average conditions, we grow a lot of grass. And then if it dries out, that grass is available to burn. We had a fire on Monday, northwest of Hot Springs. It only burned 18 acres, but it was burning actively through green grass, visually green grass. But when you walked through the grass, you realize there's so much thatch, so much cured grass that's buried beneath the green grass that fire was readily carrying through it. I just checked an email I got right before I came up here in northwestern South Dakota. Well, it was actually on the Montana side, 3 miles on the Montana side. They just had it was a 30-acre fire up there burning through visually green grass, but there was so much thatch that burned below it that the fire had no trouble burning through that particular part of the country. So it's the variability that we're concerned with. The interesting things I always like to point out on this graph is look in the 30s, right? Very, very dry conditions, Dust Bowl conditions. 50s, it was another period of drought. The mid-70s was another period of drought. And from 2000 to roughly 2006 was another period of drought, 2007, something like that. But then at the end of that period, from 2008 to roughly 2010, 2011, we had very, very wet conditions. 2012 was extraordinarily dry. So all of that grass that was able to build up to grow in those preceding years was available to burn in 2012. Well, what have we seen the past 3 years? We've seen very, very wet conditions across the state. We're seeing very, very wet conditions across most areas of the state this year. The Black Hills and northeastern South Dakota are 2 exceptions. I think Eric will touch a little bit about on precipitation so far this year. But we're not looking like it's going to be a very active year statewide in terms of wildfires for South Dakota, but the Black Hills and northeastern part of the state might see a little bit more activity. So let's talk a little bit about impacts of future climate change. Well, as Dennis talked about, we're going to see an increase in precipitation and very heavy precipitation across the state. This to me means, as a fire manager, we're just growing more fuel to burn. That's all it means to me. We're going to see more fuel out there. We're in a naturally variable ecosystem. That's what we have. We have variability across here. So if we grow more precipitation than we have a drought year, all of that fuel that we just grew now burns. Increase in temperatures. To me, this bugs me most in the shoulder seasons. So this is probably going to have the largest impacts on ag on grasslands across central and eastern South Dakota. If we see an increase in temperatures, we might be transitioning from more rain from snow. Less snowpack typically means you have an earlier onset of your fire season because if there's not snow on the ground, your grasses can definitely burn. So I'm definitely expecting our shoulder seasons, the spring and fall seasons, to expand a little bit down the road in terms of our fires. And then if we look at an increase in temperature versus the overall increase in precipitation, really the temperature signal is stronger than the precipitation signal. We're going to see more potential evapotranspiration out there, which is going to possibly lead to more dry conditions overall across the landscape. So that's kind of all I have for you guys. In terms of a fire outlook this year, like I said, the Black Hills National Forest right now, we're dry. We've been dry for the past 30 days. If we don't see precipitation in June, I'm going to have a lot of concern for our fire season come July and August. For central and eastern South Dakota, not too concerned yet. We're pretty much through the fire season for eastern South Dakota. We'll kind of have to wait to see how the precipitation patterns develop across the central part of the state to see if it's going to be an active fall this year. But I'd be happy to take any questions afterwards. We'll let Eric talk first, but I appreciate your attention. Thank you very much.
All right. First of all, thanks for having me here. Being from the University of Illinois, getting to travel up here, I got to do a little bit of reminiscing about a few things. I got to show you one thing. See the guy on the left here? This is your Vivian hailstone. You remember this from 2010? I'll never forget this event when it happened because I was teaching all about it. And apparently the story is when that stone fell, not only did it punch holes in the roof of his house, but that stone he found out in his yard. And this first thing I think he wanted to do, you guys have to back me up on this, was blended up into a daiquiri. Decided to call a meteorologist, and turned out it was a record stone. Just so you know, a stone that large, that one's 19 inches in circumference, falls from the sky at around 200 miles an hour. So that's what we're talking about. And that's my hand over there on the left. And this is why I'm into agricultural meteorology, and that is because in 2012, that's what corn looked like coming out of Champaign County in Illinois. So let's talk about what's going on right now and what we're projecting for the upcoming season, okay? So, bunch of maps. Look at the numbers inside of each state. The number is on a 122-year record. The closer you are to 122, the warmer that particular month was. It goes December in the upper left, January upper right, February in the bottom left, and March in the bottom right. We are clearly coming off of a very warm winter. In fact, here's the most recent couple of months. You got April in the upper left, and then you have, because we don't quite have all the data in just yet, but you have what we basically are going to call May in the upper right. And when you put it all together, showing you some of these graphs that both of my colleagues have been showing you for the past few minutes here, we can clearly see that this December to April time frame has been a very warm one for you. In fact, it's going to be your 6th warmest on record. We have to keep that as the backdrop as we look forward to what this season is going to bring in all the way into next winter as well. So let's do that. So to build off of what they discussed, I want you to check out this next graph. What you have running up the y-axis is the number of days. It's the number of frost-free days. This is the frost-free season. And on the x-axis, you have from 1905 to 2015. And here are the data. Now, it bounces around. This is a lot of the variability that we've been discussing, but I want you to pay attention to these next 2 red arrows I put on the screen. This one shows you that really since about 1974, you have not had a frost-free season in Huron shorter than 120 days. And then you have this arrow. This one starts here in about 2005, 2006. You haven't since that time period had one shorter than 130 days. These are the changes that has been discussed by the previous 2 presenters. Now, I had to throw in a couple of slides during the morning session, so these are brand new. I had to verify what Bill was telling you, so let's see if his numbers are right. He said that Iowa was at almost 100%. Well, there it is. 99% of the state has been planted, so good job there. He actually knew his stats. And then we had soybeans as well. He said almost 90%. There it is, 88. So let's take a look at this now for South Dakota, though. You're at 92% in your corn progress, and you are at 75% in your beans. But that is certainly not even across the state. We've got to look at what's going on there. So this is what I want to do. I want to keep all of this in perspective of yield and yield potential, and we're going to talk about it for this year. You have in this graph from the USDA NASS data set, 1948 to 2015 corn yields. Okay? You can see that I put a trend line in the middle there that kind of shows your technology, your herbicides, pesticides, your fact that you're planting more seeds per acre. That's what's showing you the increase in yield as a function of time. What we need to discuss is not necessarily where this is pointing, but what happened here and what happened here. You see, if we get a better understanding of the variability in the weather that's been discussed in the context of what produces great yielding years and what produces years where the yield is very, very low, we can understand our weather risk and better manage our weather risk as a state. So let's do this. So here we are, right where that star is in your state. And what you've got graphed on this on the x-axis is April to September. Y-axis is inches of precipitation. I grabbed your 4 best years. I'm going to color them all these blue colors, okay? The more this graph looks like a beautiful set of stairs with no landings, the better your crop is going to be. Here's your top yielding years. Nice, even, regular precipitation. It actually doesn't matter, really, if you get a ton of rain or a little bit of rain. As long as it's evenly distributed throughout the season, you tend to do very well. Let's look at the same thing for your worst years. What I want you to see here is this nice flat spot right through there. You are coming up on the most sensitive time period for the entire year for your yields. If the precipitation shuts down in the next few weeks, you're going to be watching the yield levels just drop off further and further. And I'll show you right now, this is 2016. You've started off the year wet in this particular location. We'll see that that's not everywhere in the state, but there you are. It doesn't matter that you started off wet. It can shut off. We have to be watching and forecasting that very carefully, and I'm going to show you what we're expecting, okay? So what about these last 30 days? Here's the whole country. This is the percent of normal precipitation. So look at the color coding. If you're at 100%, that's average. If you are in these bluer colors, you're well wetter than average, or if you're in the warmer colors, you're actually in the drier than average area. The Great Plains have been soaked. Texas is a mess. They've received enormous quantities of precipitation going all the way back to October of 2015. It is just flooded in some parts of that state. But what I did a few minutes ago was because of Lynn had a great comment about precipitation, I actually wanted to make my own graph and show you what we've seen in the last 30 days. So sorry there's a shift in the colors, but here we are most recently. Look at the variability across the state. That really darkly shaded, I think it's blue, maybe it's purple, I don't know, that really darkly shaded stuff in there, that's actually we're in excess of 200% of normal rain for the last 30 days. While over where Darren is now worried about fires, you see some locations where they're down there in the 20 to 40% of average. This variability is what makes your state very susceptible to a lot of changes. So we've got to keep this in the back of our minds. So Lynn, you did a great job actually remembering where the precipitation fallen across the state. I don't see him. I don't know if he's in here still, but pretty good. All right, what about the next 10 days? That's what we've got graphed here. The southern and southeastern parts of the state, I'm expecting to see more precipitation. There's a system coming through very soon that's going to drop more rain there. But after that, one of the things we do see here is that you're not expected to get quite a bit of precipitation across the state over the next 10 days. That's starting to border on the time of year where that makes things, well, makes your crops very sensitive to precipitation. It's good that it's wet going into that, though, so something to think about. Now, if I showed this graph to my students in class, this is about the time that they start getting on Facebook or they open up their cell phones and just completely ignore it. But I'm going to tell you, the information in this graph is very powerful. You see, what I've got here in blue are your great years, and in red are your bad years. It's the whole year's worth of precipitation, day to day to day, right? Let's get rid of the edges and just, not the whole year, I'm sorry, April to September. Let's just go right in here to June to July. I'm going to put a line at 97 degrees. One thing you must watch out for is that in that time period, mid-June, that's a new month, mid-June through July, you got to keep a close eye on temperatures breaching that 97-degree mark. We know corn is sensitive to it. Your worst years do it. So the question is, what does temperature look like moving forward? What does precipitation look like moving forward? And let's look a longer term than that. So here's a neat thing that we did. What you've got on this map, color shaded, is the correlation between yields in corn and July temperatures. We do this globally because weather is connected. Stuff that happens at the Pacific Ocean, stuff that happens in China, in fact, impacts the weather here because our weather translates and moves. Let's focus in on the US, though. In an ideal world, think 2014. There is a large trough in the jet stream over the central and eastern part of the United States. When it's cool, crops are amazing across this part of the world. We want to know, is this going to happen this year? Well, this is the next 8 to 14 days in terms of temperatures. What you can see is that we are going to rebound and start to warm back up. You're kind of in a little bit of a cool period right now, cooler than average, but we do see some warming coming back through this area. So this is the short term. What about the long term? One of the things I do at my company, Agrible, is we have a statistical model that forecasts temperature anomalies. July, August, and September, we're actually forecasting for the northern part of the United States and also the rest of the Corn Belt, for that matter, to be warmer than average. Now, what does that mean? If we get through July before this heat takes place, generally, things are fine. If it comes early, which is what we're starting to watch right now for that to happen, that has a big impact on ag. But this is what the forecast looks like. Most of the heat that you see here is later in this time period, not necessarily at the beginning of July, but maybe more toward the end of July, August, and September. This information is also kind of confirmed by 8 national dynamical models that are run all the time by the US government. Same picture shown here. The warmer colors indicate warmer than normal conditions. How do you digest all this? What do you do with it? Well, my main points kind of get you the idea here. Low probability of cooler than average temperatures for this summer. There is a high probability of average to above average. We got to keep an eye out on if it gets too hot at the wrong time. When you see these graphs, don't flash back to 2012. Right now, if it was 2012, we would have already seen numerous days breaching 90 degrees, 95 degrees. We're not having a year that is analog to 2012. But for the first time in a few years, you're going to have a warmer than average summer. At least that's what's looking like in the forecast. Let's talk about drought. One thing you can see right here is that, for the most part, your state is void of drought at this point. Yes, some drought has creeped in recently. In fact, Darren and I were talking about this at lunch. You've had a little bit of drought that's moved in since this map was created into the western part of the state. What you've got here on this x-axis is time from 2000 to present. On the y-axis is the percent of your state covered in different levels of drought. One of the things that is very good about this upcoming season is that we're not going into the season, into the main part of our season, in drought across much of the state. Whereas your bad years, so think 2002, 6, and 12, you had already established drought at this point. So keep those pieces in mind as I give you the end part of my part of this talk here. What about this? What about the correlation of precipitation? You want to be wet, but not too wet. That's all that this map says. Excessive rain, as was talked about, is way too much for your crops. You have low-lying areas that can't ever get replanted. You get past your window of planting, and that's a prevent plant acre. So you can clearly see you want to stay a little bit wet, but not too wet. Here's our forecast for the rest of the season. What you can see in this graphic is that we're having basically a forecast of not too much in terms of precipitation stress across the country, especially in the main growing regions. Ignore the fact that I have this big dark blue blob over the four corners. That's a desert. What that shows you there is that if it rains an extra 1/10 of an inch, it shows up dark blue on my graph, okay? I also want to tell you this, and this is very, very important. If I could forecast precipitation months and months in advance with extreme accuracy, if anybody on the face of the earth could do that, we would not be having this Ag Summit in this building. I'd invite you to my island to talk about it, okay? So this is hard to do, but this is at least the patterns that we're looking for. Right now, I am not forecasting widespread drought to move across the United States. Neither are the global models. So what you're seeing here is potential heat stress without necessarily having the widespread water stress. And what I want to do is I want to take all this information and kind of build one last point for you. Let's do this real quick. I'm going to get through these slides just in the sake of time here. You're going to hear a lot of people talking about El Nino. If you're talking about El Nino, you've missed the boat, okay? El Nino is done. A little bit of fun trivia for you, though. Does anybody know who El Nino's named after? You can't answer. Anybody know who El Nino's named after? Oh, good. Who is it? Jesus Christ, that's right. The El Nino is always capital El Nino. It's named after him. Peruvian fishermen, late 1800s, I think, began to name this particular event. And all that it is a warming of the waters across, well, that big oval that I have there. Do you see right now how the waters are cooling? The current El Nino event is crashing hard, as all big El Nino events that we have record of have done. That means we're moving into La Nina. And La Nina is the opposite phase, where instead of having warm water across the open Central Pacific, we have cooler water. There are connections between this and your weather. Are they perfect? In other words, if something happens in the Pacific, does it mean something's going to happen here? Absolutely not, but it's a driving factor we have to consider. El Nino is back into its normal phase. The ENSO cycle is back into its neutral phase, and we're heading toward La Nina. And this is what it means. When that cool blob of water takes shape later on this month and over the subsequent months, what I think you really need to be thinking about is maybe what winter is going to bring. So we'll talk about that in a minute. Here's the last couple things I want to show you. So you looked at this graph. We can see that we're on this upward trend. A perfectly average year for corn in this state, 149, maybe 150 bushel an acre for the whole state as an average. Given all that you've seen, what are we forecasting for the state this year? Well, I'm going to show you some of the work that has been done by my company, and this is our large-scale kind of statistical model output. This is what we're saying. Oops, clicked way too many times there. My forecast for your state this year, 150 to 152 bushel an acre. That's +3 on your average. That's down 7 bushel an acre over what you had last year. One of the reasons why you're probably going to have a pretty good year here is because even though there may be some temperature stresses, it does not look in the short term like you're going to see the water stresses. So not as good as last year, but certainly not one of these years that just falls off the bottom here. Same thing for beans. We ran beans this morning as well. One last thing to show you is this, kind of one last ugly graph. Each circle on the graph is a temperature and precipitation pair for any given year going back to 1950. So the way that you need to look at this, and this is for winter now, this is December and January, is each December and January from 1950 to present gets its own circle. I've colored in red El Nino winters. This year's El Nino winter, I'll point over at this one, is right there. Can you even see my laser pointer? I'm not sure if you can see it. It's this outlier over here. This was your warm and relatively wet winter. You can kind of see the warm is going up, the wet is, the cool is going down, and the wet to the right and the dry to the left. When there's an El Nino, look at how more of the red dots cluster above the zero line suggesting warm. When there's a La Nina, notice how things return back more toward normal, and even in fact, there seems to be more of those winters where you are cooler than average. So while this past winter was warm and wet, and likely going to set you up for a good season in terms of your crops, next winter, based upon this one driver alone, which is not a good forecasting technique, but it is part of the way we do this, looks like you're going to go back to having one of your more colder and snowy winters. So with all of this, we want to open this up to questions, and please probe, ask hard questions, get us to think, because it's the only way that all of us are going to learn together. So thank you.
So to play off what Eric said, if your husband or wife has been harassing you about spending some winter in the South, this winter might be the one you want to take advantage of that.
Okay, much the same format as the previous session. We've got Paul in the back, and we would open it up to questions from anyone in the audience.
One other thing I'd like to point out is Eric was talking about low yield years of 2002, 2006, and 2012. Those were also bad fire years across South Dakota. And so it's a lot of the same stressors that act against crops that act to promote wildfires.
Questions from the audience? What about the panelists? Do you have any questions for your colleagues?
Yeah, that's a good thing to ask.
So one thing meteorologists always joke around about is the skill of our forecast. So Eric, you being a small business owner, what's the overall skill of your forecast, historical skill?
Yeah. So I showed you some projections, 3-month projections, and what is the skill? From our particular forecasting technique, we're at about 70% accuracy in terms of direction of the temperature forecast out to about 8 months. So 70%, that's what we're looking at. In terms of precipitation, we're at about 58. It's very difficult to do that long-range projection. On the shorter term, it's a much different story. We're not talking about short-term weather projection. I'm talking about stuff that's 1 to 7, maybe 1 to 10 days out. So when I show you this stuff, you need to be looking at graphics like this in terms of patterns, in terms of planning, in terms of these are the most probable events. I did not give you solid gold. This is exactly what's going to happen. And we can't do that. And if you ever find a meteorologist that talks in absolutes, you need to find another meteorologist because they're just full of crap. I'm sorry, they don't know what they're talking about if they do that. So yeah, excellent question.
And to go along with that, part of the problem is, we've talked about extremes. Extremes are some of the biggest drivers of some of our issues. And our ability to forecast extremes is even worse than that because we can't go out on a limb that far and say with certainty. And I shouldn't share this, but I will. There's been another private company, not Eric's, that has been beating the drum about this being another 2012, and they were doing it since last winter. And this was one of those absolutes that nobody in the climate community could back that up. There was just no way you could do that. So I think there was a question over here.
Eric's map that he showed, trends are drier right now in the eastern Corn Belt. Is that right?
In the short term, I'm sorry, I don't know who's speaking.
Right here.
Oh, there you are, sorry. In the short term, like the next 1 to 10 days?
Well, I don't know, just the color of rainfall. You had blue or one of them last maps.
Yeah,
it was
can we bring it
white
back
in
up?
the.
Let's look at it again real quick, if you don't mind. I don't
I'm
know
not
if
sure which one. It appeared to me that
I wanna know.
Illinois, Indiana were drier, but maybe I'm wrong about that. I'm just curious about what the situation here in the Great Plains and down all the way into Kansas has been wet. But one of them maps was, what's the eastern Corn Belt? Maybe that's the one right there.
Yeah, so right now, when you look at the, so let's do this. Where are we at going into this? So right now, the eastern Corn Belt is not in drought. But when you look over the longer term, we are at about 90 to 100% of our precipitation. Kind of, you look at the graph there, the figure, and look at the eastern part of the Corn Belt. What's been good about our precipitation, though, is we've been receiving it very regularly. Every 3 to 5 days, we're getting another event. So for the eastern Corn Belt at this stage, I'm not concerned about precipitation. What I'm very concerned about for crop where I'm from is actually going to be heat stress. Because in Illinois, our average high temperatures in July already borderline on stressing a corn crop. So we even have a few days when corn is pollinating where we get above that. Our ears just shrink, they tip back, and then we get less and less and less corn out of them. So yeah, certainly the eastern part of your state is wet going into this. And we're expecting that big, large, cool colored blob there to receive more precipitation for the next 10 days, while the west, as Darren pointed out, is expected to stay drier. But yeah, that's kind of the overall precipitation trend. Did that answer your question? You're talking about eastern Corn Belt. Sure, so I'll give you the numbers that I have right now for Illinois. Illinois, if we had a perfectly average year for yields in corn, we'd be at about 175 bushel an acre. 14, we hit 200 as a state average. We're forecasting this year Illinois to be down 6 to 8 bushel an acre. Even though things look beautiful right now, I'm driving through fields where the corn stand looks amazing, very few wet spots. I am very worried about, and my model's picking up on the potential heat later in the season. That's the same for Indiana and parts of southeastern Iowa and parts of Missouri. I'm actually seeing the northern rim of the whole Corn Belt doing much better than the southeastern part of it. And that's heat stress. Ohio, it's kind of funny. We actually have Ohio being wetter than average this year, keeping it a little bit cooler than the rest of the Corn Belt, and as a result, they're going to do well. And what we're worried about, and these guys I'm sure could back me up on this, is that with the, there's this thing called the Bermuda High. Big high pressure system sits out in the Atlantic. We keep seeing it migrating further to the east. And as it migrates, try that again, further to the west, and when it does that, it tends to push precipitation up through the central part of the country and get this little ring of fire of precipitation that goes around it. And as a result, that's actually why the long-range forecast for precipitation tends to have, sorry for all these slides, tends to have wet right in through here and drier or near average inside of that hole that you see right there. So I expect, actually, you all, again, like you did in 2015, to do better than the Eastern Corn Belt did.
I have a question. First of all, gentlemen, thank you for a very interesting panel. But I'm struck by your curves. The Bible talks about 7 years of good and 7 years of lean. Your curves seem to almost show 1 year good, next year bad, next year good, next year bad. Am I missing something?
In short, no. The climate that we have in South Dakota, and Dennis, I'll let you touch on this too, there is no normal here. It drives me nuts when TV meteorologists say we're 7 degrees above average, because there's really no average. Our average is variability, and it's a year-to-year variability. We might see it 3 years, in 3 years, but there's extreme variability. Now, there's also long-term patterns, which, I don't know, do you want to touch on that a little bit?
Yeah. And we are in a different climate here than what you think about biblically, because that is a more Mediterranean climate. This one is a middle of a continent. Because we are in the middle of the continent, we are much more highly variable in the way of temperature and precipitation over time. Because the thing I didn't go into when I talked about our climate is, well, and Eric kind of led into this, with the Bermuda High, we are fortunately in an area where we get more southerly flow, and we have to have that southerly flow off the Gulf of Mexico bringing more moisture to us on a regular basis for us to be wet. When that doesn't happen, that's when we get our dry areas, or when that moisture is cut off from us and we get more southwesterly wind or northerly winds, we don't get as much precipitation then. So it is our location that is in the middle of the continent that we are a much more highly variable climate. In technical terms, it's called a continental climate.
You guys mentioned TV weather, folks. Can you explain, we hear the European model and the American model, what that means?
Yes. We're not going to get jingoistic about the Europeans versus the Americans, okay? There are actually a number of different computer models that are used. There are actually a couple different models that are done in the U.S. There is actually two different ones in Europe. One called the European Community one, and the British have their own separate one. And what you do is you look at the different models and you look for consistencies or inconsistencies. The European model has a tendency to do a little bit better on a little more frequent basis, but not always. So you look at what the models are, and the basis of the model is just where it was developed. It doesn't mean that the Europeans versus the Americans. It's more where it was developed and who put the work behind it. I don't know if you guys wanted to.
Yeah, the European model, they've just dumped a lot of money into their infrastructure, and they have great computing capacity. Our long-range model that would be comparable to the European model is called the GFS. Over the past 18 months, it's gone under significant upgrades, basically quadrupled it in power, narrowed the resolution of it, and we're doing much better, but we just don't have the statistics quite yet to show how well it is doing. But in my opinion, we're doing much better now as compared to our European counterparts. And we have international conferences, all of us collaborate, all of us talk, and so it's not this competition that I think some of the TV media make it out to be. It's just, it is what it is, I guess.
I'll say one last thing. If you'd like to have regular access to what's called the ECMWF, that's the European version of the model, so my company considered purchasing access to it. The price tag, $250,000 a year. So it's a privately funded, basically how they pay to have their model run. Where the GFS, each of us puts in a little bit of money, and we have a similar model that runs globally. I'll be honest, for day-to-day things that most of us use the weather for, it doesn't matter which one you use. In fact, for most of you, you're going to be using what's called a model output statistic number that you get for your daily high and low, which means they take all of that model information and process it to give you a much better end result. So yeah, they're really loving this whole US versus Europe thing, and we kind of just laugh about it because it doesn't matter. We use all of it when we make a forecast. We use every bit of information we can. Good question.
Darren, with your expertise in fire, I'm just curious, and I don't know if it ties into ag today, but I think we all might be interested. What's your quick observations about the devastating fires in Canada?
In April and May, Canada had a very large, what's called upper level ridge. Basically, all of this extremely warm air pushed up into west central Canada, very abnormal for that time of the year. And they were very, very, very dry for that time of the year. So they had above average temperatures with below average precip. They also had below average snowpack up there, and so there wasn't a lot of snow on the ground to begin with. When that fire started, it's really interesting, if you look at all the satellite imagery, all of the lakes around that fire were still frozen over. They still had complete ice cover. So all of the vegetation was pre-green up, and so it's just basically a lot of dry twigs out there that were susceptible to burning. The other thing about the town of Fort McMurray is it's completely encompassed in what we call the wildland-urban interface. There's dense spruce forest, black spruce forest growing all the way up to the town, a road, and then housing developments. And so that fire came in with 300-foot flame lengths on the forest, and I mean, a 2-lane road's not going to stop that forest fire. And so it was just kind of a blend of human disaster, building in that wildland-urban interface without any space between homes, and the forested ecosystem out there, and then two, just the dry, hot conditions and the low snowpack that they had earlier this year.
I'm sure you can't answer this highly accurately, but I'll throw it out there. Global warming, what's the 25-year outlook for this region of the country, and how accurate can you even try to make a guess at something like that?
Okay. That is part of when you're looking ahead, that's always an issue of trying to assess what's going on. And that question comes up legitimately of trying to figure out planning. The overall assessment is we're going to continue to get warmer. We're likely going to continue to get wetter. Precipitation is less well handled by the models, so that's a little bit more questionable area. The other problem with 25 years is that when you look at these variabilities, there are other variabilities that we've been talking about still drive the El Niños and some decadal sorts of things. 25 years, we could be influenced by some of these other decadal variations more so than global warming, than the overall changes in greenhouse gases. So 25 years may not be a good predictor. When you're looking further out, in the 50, 100-year period, those are probably the areas where we're expecting to see some of these larger changes. Now, the problem that we get into, and when we're dealing with ag people, and this is not lost on you folks, not lost or here, it's this understanding of the interannual variability, because we need to know where we're going on a longer term, but we need to also understand some more about these interannual variabilities so you guys can plan better. Some of the environmental issues that we talked about this morning in the way of flooding or nitrogen loss or whatever could be better managed if we can give you a better assessment on what's going to be happening in a nearer term. I had a guy from Pioneer caught me after a session this winter, and he said, we managed things last spring because we were very dry going in, and then we suddenly got very wet in May. He said, if you could have told us that, we could have managed a lot better. We could have saved a lot of nitrogen. But that's something that we need to continue to work on, is some of these projections and helping people understand what we're saying in projections so that we can make better decisions. Something I think we all want you to take away from here is that we're not saying that projections or forecasts are bad. We just can't tell you everything you want to know, and we need to help you understand the projections we're talking about so you can reduce risks and increase your ability to make money.
Other questions?
So this week is the 5-year anniversary of the Missouri River floods, and Dr. Toddy, you were quoted in the Omaha paper about not if but when it's going to happen again, not to pick on you. But that was an event that caught the Corps by surprise, caught the states by surprise, caught the media by surprise, caught us all by surprise. In your discussion of variability, how do we get more accurate on those kind of events, as localized as it may have been, and is there any way to get more accuracy, more lead time, as it were?
Okay. Thanks, Jerry. Give me the easy ones. I appreciate that. Okay, back to the comment. Yes, it will happen again. Will it happen in our lifetime? Probably not, but it will happen again somewhere along the way. The problem becomes in trying to match up what is going on currently with what we know may be happening. And because when you review the 2011 flood, there were about 3 or 4 things that all occurred together. You remove any one of those, and the flood doesn't happen. We have high flows, but we don't have the flood. You had pre-setting very wet conditions. You had a big plain snowpack. You had a big late developing mountain snowpack, and then monster rainfalls in Montana. You remove any one of those, and it's a minor issue. It's a non-issue. What actually was a good outcome of the 2011 flood has been what we call coordination in the way of climate services, where there's been more coordination among people in the basin, including the Corps of Engineers, including NOAA, including USDA, talking about what's going on and then looking at the potential problems that could come up. Where are we now? Okay. And Eric did some of that too. Where are we now? What are the potential issues we could see? Could this be an issue? Could something happen that there could be an issue? And then we can start at least letting people know somewhat ahead of time. So that's been a good outcome. The Corps has been brought in these conversations, so they've been more open talking about what's going on and trying not to catch people, because yes, I was caught off on the 2011 flood. I got a call from another media outlet asking about this, and I said, well, this shouldn't be a big issue. And then the next day in the office looking at this going, oh, this is not going to be good. And Darren can tell you what he got to do for the next several weeks after that one. So it is about, and I'm going to take off on this one more point I wanted to make that I think is critically important that we need to stay abreast of and support. How many of you have a cell phone? How many of you have an app that on your cell phone that tells you what your temperature or precipitation is? How many of you have more than one of those? Okay. The importance that I want to talk about is in the way of monitoring. We have in some ways become complacent, thinking that, well, we just know what we know from an area just because we always do that. The only way that comes about is by monitoring, that there are actually instruments out there measuring what's going on, and that data is collected and absorbed and used. And there's been more interest in private entities, and those are fine, but there needs to be continued support of monitoring in the way of temperature, precipitation, a lot wider variety of things, because that's the only way we really know what's going on, and in common ways of monitoring, so we're doing it the same over a long period of time, and we can see how changes are occurring. Because we can talk about changes, if we don't actually monitor the changes, we don't know exactly what's happening in the way of changes, and that's really, really important that we don't ever get complacent on that.
In the far back row.
Dr. Toddy led into my question I was going to ask him. Do you want to take a few moments to talk about coca rods?
Yeah, we can do coca rods. A playoff, thank you on that, from the monitoring standpoint. What is the most variable thing that we measure in anywhere in the middle part of the country? Precipitation. And we have a problem in South Dakota, and that the way that we can tell some of that variability is by having radar coverage from the National Weather Service radars. Well, we have large parts of the state that are a long way from those radars to be able to give us good definitive answers for what's happening in the way of precipitation. We are part of a national volunteer network called CocoRAS, the Community Collaborative Rain, Hail, and Snow Network. It's cocoras.org is the website, and it's a way to do citizen science. Anybody can measure precipitation, report to this website, and then that data can be used by anyone within about a minute of you putting it in. It shows up on a map, so it's not you're collecting data, you don't know where it goes. It goes to be able to be used. We use it when we're checking drought or flood events, who's getting rainfall, who's not getting rainfall. We're able to check flood events really well. The Sioux Falls flood back in August, we had CocoRAS observers that gave us very good measurements of over 7 inches of rainfall to be able to tell. There was a flood in Midland last May that we probably wouldn't have caught the amount of rainfall if it hadn't been for a couple CocoRAS observers. So it's a way of being able to define what's happening in the way of rainfall. It's a check on you for you to be able to say, insurance program or whatever, here's telling me what they said we have for rainfall. You can measure and say, is it right or are we getting it wrong? So it's a really cool thing. I would encourage you or your companies or entities to encourage your members to be involved. It's very, very helpful to all us in the state.
Other questions? I guess I do have one for the panelists, and this might be kind of a silly question for those who are educated on the topic, but I know I hear a lot of people talking about it. How long do these El Nino and La Nina patterns last, and what drives the changes?
We can tell you what, I'll just go over here and show you. So to answer the second question, what causes the changes? Honestly, we don't have a definitive answer. El Nino is probably would you call it one of the largest global circulation patterns we have? And this graph shows you the periodicity of it. So you can see this goes from 1986. This is actually wrong. I apologize. Something happened when I put it on that actually goes from 1990 over there on the left-hand side to 2016. Looks like my dates got screwed up when I transferred it over. What you can see here is that the big peaks. So you mentioned 1997, 98 as a potential analog here. That is the peak that you now see July of 1993. So those dates are wrong. That's 1997, 98. But look at how short they tend to last, the big ones in duration. The one that we're currently experiencing is probably a 15-month-long event. When they get big, they crash hard, which is what we're seeing out of the current one here. So when we're talking about variability here, this is subdecadal. There are some decadal oscillations that happen as well. One of the ones that we should be paying attention to is one called the Pacific Decadal Oscillation. There's also one in the Atlantic and one in the North Atlantic. In fact, there's like 20 of these things that nerds like us watch all the time and care about because they influence the weather around here. El Nino is just the one that gets the most attention. So there you go. That graph and the variability that you see there is the answer. Good question.
And the problem is some of these, like El Nino can be forecast several months in advance fairly well. Other ones that are very influential sometimes can't be forecast in much. There's one called the Arctic Oscillation, which greatly influences our temperatures and some about our storm track, but we can't forecast more than 6 weeks, maybe. Yeah, very much in advance. So it's an influencer, but we can't predict it is the problem.
So just for perspective, you asked about the Missouri floods of 2011. 2011 is the last time we saw a decent La Nina event in the Pacific Ocean. The same La Nina persisted through winter of 2011 into 2012. Now, based upon the graphic that I showed you up there at the very end of my presentation, if we had La Nina conditions, generally it's near average temperature or cooler than average temperature for winter. But in 2012, we had this Arctic oscillation, which is basically the speed of the winds around the polar regions of our planet. Those winds were fast. They kept all of the cold air locked over the North Pole, and we were setting records in March. In fact, in Champaign, we were like 87 degrees the first week of March, which is what we typically get the second week of July. So this is how these longer-term changes impact the shorter-term things. And the good thing is you have, I'll be honest with you, so I'm from out of state. You have fantastic in-state meteorologists. I wish you would listen to these guys more because they have a good handle on what they're talking about. I love it when I meet people that actually know what they're talking about. And so this is very good. They're underutilized, in my opinion, which means they need to raise, and they need to be in front of you more often, okay? So anyways, yeah, this is exactly what we talk about.
This paid political announcement was brought to you by...
Any other questions? All right, seeing none, I'd like to thank these gentlemen for your insight and your comments, and thank you so much for joining us.